So let us look at an example. So in this example, it is an example for rotameter. Example 3 here is saying that a rotameter is to be designed to measure a maximum flow rate of 400 liter per minute of water at 27 degrees Celsius. This should be not here, this should be degrees Celsius. The float has a diameter of 15 mm and a volume of 3 ml. The effective density of the float is twice the density of water. The total length of the rotameter is 250 mm and the diameter of the tube at the inlet is 15 mm. Determine the tube taper coefficient if the drag coefficient of the flow is 0.8. Right? So the question here is asking us to find the value of A, the taper coefficient. So let us see what information is given to us. So we are given the information of Q. So again, a good practice is always to write all the information that you have. 400 liter per minute. Okay, so mind the unit, it's liter per minute. And then we have the diameter of the float. So we can say D is equal to 15 mm. And then we have the volume of the float. So VF is equal to 3 ml. Right? So again, mind the unit. The density of the float, right, rho F is actually equal to 2 times density of water. So I can write here rho F is actually equal to 2 rho, because we said that here in the equation, rho F is the density of the float, rho is the density of the fluid flowing in your rotameter, and in this case, the fluid that is flowing in the rotameter is our water. Okay, and then the total length of the rotameter. So we can say that the value of Y, the height of the rotameter, is 250 mm, and then the diameter of the tube at the inlet is 15 mm. So this shows us that the diameter at the inlet of the tube is same as the diameter of the float, right? Okay, and then we also know that the drag coefficient, so the value of CD is equal to 0.8. So let us just go to this equation and see what information do we have. So we have the information of Q, right? We know it's 400 liter per minute. Gravitational acceleration, we already know. The volume, VF, you know, it's 3 ml. Rho F is known to be 2 rho, right? So we can say this is known. This is not known. This is not known, right? This we don't know, we don't know. CD, yes, we know. AF is not given to us, but we can always find the value of AF because we know the diameter of the float, right? The value of A is the value that we want to find, so we don't know that. And then we know the value of D, and then we know the value of Y, which is 250, right? So we have a few unknowns. So let us see what are the unknowns that we do not know. So first of all, we do not know the value of rho, right? Rho we don't know. And then we don't know the value of AF, right? So is there any way for us to find the value of rho, right? No, nothing is given, right? So we have a temperature. So maybe we can use our steam table or our appendix to find the density of water at 27 degrees Celsius. That's a possibility. So we just keep it, right? We just hold on for a while. So let us see, the easier way for us to find is the value of AF. AF is the area of the float. So we know that the formula of area, right, the cross-sectional area is pi over 4 d to square. So we already know the diameter, so we can easily find the value of AF, right? So we have, in a way, all the values, so we can actually try to solve for the value of A. So let us see. So first of all, right, I mentioned just now, unit is important and we have to mind our unit. So the easiest way for me to solve this question is actually to change all the units that are given to us in the SI unit, which is our meter, second, what else is there? Yeah, kg, right? So we have three here. For gravity, we have meter per second square. We can have volume in terms of meter cube. Density, we can have in meter cube per kg. And then everything else, AF meter squared, D is in meter, Y in meter. So change everything into a common unit first. So 400 liter per minute, convert it. Okay, try to convert it on yourself. What is the conversion factor of 1 liter to 1 meter cube? What is the conversion factor for 1 minute to second? So if I'm correct, 400 liter per minute is actually 6.67 times 10 to the power of negative 3 meter per second. So this is already in meter and second. The volume which is given to us in 3 milliliter, I change it into 3 times 10 to the power of negative 6 meter cube. So I change milliliter to meter cube. So this is a conversion between milliliter and meter cube. The area of the fluid, right, AF, is, as I mentioned, pi over 4d squared. So D was given to us. D is actually 15 mm, which is also equal to, so milli has a unit of 15 times 10 to the power of negative 3 meter, which is also 0.015. So you will get the area AF 1.17 times to the power of negative 4 meter squared. And then rho F, the density of the fluid, is 2 times the density of water. So if we substitute all this value into this equation, right? So if you see here, there is no longer the term for density. So what does it happen here? So if you look at here, I just take this part of this equation, right? I just put it here. So rho F minus rho. So we know that rho F is actually equal to 2 rho. So what I do is that I put 2 rho minus rho. So I will get a value of rho. So if I change this one, instead of writing here 2F minus rho, I put here just rho. So I can cancel out rho and rho. So just now we said that we did not know how to actually find the value of rho. We did not know the value of rho. We were thinking maybe we can use the temperature to find the density of water, but actually if we substitute into this equation, we can just cancel out the value of rho because of this relationship between the density of the fluid and density of water. So that is how we get to this equation. Now we have calculated, we know the value of G, we have calculated the volume of the fluid in terms of meter cube. CD was given, AF we have calculated in terms of meter squared. Pi over 2, A is the value that we want to find. D is known, 15 mm, we change it into meter. And then Y is 250 mm, we change it into meter. So and then the value of Q here, we already changed it to meter cube per second. So substitute all the values and then you'll get the value of A, which is our taper coefficient, which is 1.76. So this is the final answer for the example number 3.